So we are joined live by Dr. Kim Cobb, and her Twitter page explains everything she does in the best possible way. It is that she is 40% climate scientist, 40% mom, and 20% Indiana Jones. And indeed, her work has taken her all over the world, from the remote Pacific to the Bornean jungle, in pursuit of understanding the mechanisms of climate change. As an educator, she's been featured all over the world, including in like congressional testimonies. She is really cool, and she's a mother of 4 to boot. So proof that life, you can balance work and play and family and all that good stuff. Without further ado, thank you so much for joining us for our Oceans Week, Dr. Cobb, and take it away.
Thanks so much for that rounding introduction, and I'm very, very excited to be here today. This is my second time on Exploring by the Seat of Your Pants, and I love talking to all kinds of ages about climate change and coral reefs and what scientists are trying to do to figure out the ocean's role in climate and how we can use the ocean to get us out of this mess and really protect the ocean going forward for your generation and the generation of your children as well. And so also, I just hope that some of you, actually maybe even 1 or 2 of you, I would be super happy if 1 or 2 of you decide that you may want to be a marine scientist when you grow up, just like me. Because when I was your age, I didn't know you could actually grow up to be a marine scientist. I thought you could grow up to be, you know, study whales or starfish or dolphins like I'd seen on TV, but I didn't really know what a marine scientist does and how many of them are out there studying all aspects of the ocean. So I hope you can partake in as many of the ocean-themed Exploring by the Seat of Your Pants as you can this week. I know many of you are rounding out a really long school year, so this is a super great way to get those last bits of inspiration in and try to put the pieces together of where the science that you learn in the classroom and the science that we do as researchers to try to advance knowledge. It's all one and the same thing, but sometimes it's a little bit hard to see when you're sitting in a classroom in the first week of June and summer staring you down the face. So thanks for being here, teachers. Thank you for your support of this organization and science in general. Y'all are my heroes. So I have 4 children. I have my daughter just ended 6th grade. My son just ended 4th grade. And my twin girls just finished 2nd grade. And so this is just my sweet spot of all the different kinds of different age groups to talk to. And I look forward to all of your questions. The best questions I get without fail are from students. So adults think they know all the answers, but actually they don't. And you really help us think about things in new ways. So be queuing up those good questions for when I ask for them in about 20 minutes. But first, I'm going to talk a little bit about my research. You know, people always ask me how I got to be a scientist and why I do what I do. So I hope by the end of these slides, you understand why I do what I do and why I think it's important and what you can do to help us as part of the climate ocean solutions. So let's get going. Let me see. We've practiced this so many times, so hopefully it's going to work out. Okay, can you guys see that?
Perfect, yes.
Okay, great. Good. So this is a picture of our Earth from space. And so this is a Google Earth image, and this is the Pacific Ocean. And so we don't usually see a map of our planet in this light, but here we are on a planet that is covered 70% by oceans. And this whole side of our planet is basically one big ocean called the Pacific Ocean. So much of the Pacific Ocean determines everything about our climate system and life on Earth that to me, it's just the most inspiring feature of our planet. Not the little land pieces that we walk around on, but the great Pacific Ocean. And in the very middle of the Pacific Ocean is my lab. And that's an amazing place called Christmas Island. And I'm going to show you some pictures from Christmas Island in a minute. But we go there to study the middle of the Pacific Ocean because that's where the climate signals start that impact all the global climate system. So that's chasing down key aspects like the center of our climate system. Actually, you can trace to the Pacific Ocean because it's so big. And so if we go to look at some of the pictures of these places, they're absolutely beautiful. They are just, stunning paradises for the most part. They can be very, very wet, like this one, which is covered in palm trees. This is actually called palmyra because palm tree, you know, palmyra. And then, or they can be somewhat more desert-like because of the different ocean temperatures across this region. But these places are just places that you fall in love with the first time you see them, like me. And so I was first down at these sites in about 1997. And I was just convinced I had to find a way to keep coming back to these remote tropical paradises for the rest of my life. And that's exactly what I did. You guys still there? Okay, good. Just making sure. Okay, and so this is another picture of the shoreline of one of these islands. This is obviously showing you where the water meets the land. And these are islands that are really, for the most part, uninhabited. And they have a mixture of really rare land creatures like coconut crabs that are really huge crabs. They, you know, are bigger than my face. And for the most part, they've been eaten to extinction across most of the Pacific Islands. But in many of these islands, they're still walking around and they eat coconuts. And so their meat tastes very good, but, you know, I'm not going to do that. Plus, I'm vegetarian. So here is a picture of me diving on the reef at Christmas Island, and you can see that I'm holding a very, very heavy piece of metal. There's an even bigger piece of metal behind me that my assistant is holding. And these coral cores that I'm pulling out of this coral colony are telling us something about the ocean temperatures of the past. And so in this very, very, very remote region of the world, we just don't have many records of ocean temperatures to tell us what ocean temperatures were like before we started this global warming experiment that we're doing right now. And so these coral cores can extend back several hundred years. It's absolutely amazing. And these coral cores grow about 1 finger width per year. So if everybody holds up your finger like horizontally, that's how fast the corals are growing. They're not very fast, right? No, not like this. Don't point to the ceiling, point to the walls. That's how fast the corals are growing, not very quickly. And so what you can see here is that these coral cores are difficult to get because you have to retrieve them by scuba diving, and it sounds all very fun, but when you're operating a 200-pound drill underwater, it's pretty demanding stuff. But again, very precious information about past ocean temperatures. And so what these records have allowed us to see is, of course, the pattern of ocean temperatures that we had before they started burning fossil fuels and creating greenhouse gases were different than they are today. And in particular, we had an ocean temperature extreme in 2016 that I'd like to tell you a little bit more about because it really hit my sights pretty strongly. And so this is a picture of me scuba diving on the coral reef at Christmas Island. And you can see here that this is an instrument I'm installing on the reef. So I'm not drilling this reef, but you can see it's a very, very healthy reef. Lots of different colors and sizes of corals, just like you would expect on a remote Pacific reef where humans haven't been doing lots of damaging things to the reef, because generally it's very hard to protect reefs from overfishing and dredging and extra nutrient runoff. But these are reefs that are really far away from most human impacts. And this is just a stunning example of a remote Pacific reef in all of its beauty. And I'm installing that temperature sensor so that we can monitor ocean temperatures through time. And so this is August 2014, and this was way before we had that really big ocean warming in 2016. And that big ocean warming in 2016 is called an El Nino event. And it's a natural source. Raise your hand if you've heard the term El Nino event. Maybe some of the high schoolers. Anybody? I see some hands going up. I see, okay, more hands. All right, that's okay, good. You guys are getting there. And so El Nino events are something that are born in the middle of the Pacific Ocean. And that's actually what I chase because they're so strong that they impact climate all over the world. So no matter what classroom you're sitting in, from British Columbia down here to Atlanta, Antarctica, even Greenland experienced the impacts of El Nino events. And so you can imagine how exciting it is for me, who's somebody who studies El Nino, to study the El Nino events in the heart of the Pacific Ocean in their birthplace, knowing that the rest of the world will be feeling those effects as well. And that's one of the key questions in climate change we'd like to understand, is how these ocean temperature extremes are changing, because that impacts temperature and rainfall patterns all across the world. And so this is coming back to this photo. This is me installing a temperature sensor before the very, very large El Nino event of 2016 came. And let's look at what happened during that event. Here's another picture 2 years later, on 2016, when we see a reef from the same site. So this is the same one I showed you. Here's the before, and here's the after. And this is a reef that has been mostly killed by that very, very large El Nino event, that very large and very long ocean temperature warming that occurred in 2016. And so, you know, people want to look at how do you know it's dead, you might ask. And in this case, we're looking at a reef that has this brown, red, fuzzy stuff all over it. And when you're diving on the reef, you can see that like wafting in the currents, like a shaggy carpet. And it's basically an indicator that red-brown algae have completely colonized those dead coral surfaces, and they're making a run for it on the body of the dead coral. And so kind of a grim picture. Now, there are some places where, I don't know if you guys can see my cursor, but I'm trying to show you some live coral there. If you peer closely, you can see some yellow tan things that I'm trying to circle one's kind of like over here on the left, and then there's a big piece of pokey stuff over here that looks like a branching coral that's also kind of, you know, that mucus yellow that indicates a living coral. So there are some living corals on this reef, which is actually absolutely astounding. It's actually almost a miracle that they did not die during the largest ocean temperature event to ever hit this reef. They lasted over 10 straight months of temperatures that killed all of their neighbors and then some. And so as a scientist, we are drawn to these kinds of corals because they may hold the keys to corals resisting ocean temperature change in the future. So maybe these are the kinds of corals that can survive a warmer world. Maybe these are the kinds of corals that have the right genetics, or the right algae symbionts, or the right lipids or fat stores. Who knows why? I'm just speculating. We don't know why. But we're really, as scientists, very interested in going out and studying these kind of corals to help us unlock the keys to coral resistance and coral resilience. So they hold the keys. They're the survivors, and we call them our miracle corals. Okay, so let's think about what's next for coral reefs, because what I've shown you is a large amount of data that goes in over 20 years in my lab, looking at ocean temperatures of the past and then bringing it up to the present in terms of looking at what's going on today and recognizing that ocean temperature event in 2016 was something that didn't just kill the corals at the reef that I work at in the middle of the Pacific Ocean, but it actually killed a large amount of corals on the Great Barrier Reef, across the Indian Ocean, the Atlantic Ocean, and major reefs of the Pacific, north and south. And so this was a global temperature event that killed many, many corals and bleached and weakened many others. And so as the world warms further with fossil fuels and climate change, we have to ask how the corals of tomorrow are going to weather the warming that we know is coming down the pike over the next decades. And so everybody always asking this question, you know, are corals going away? Are they going extinct? Are they going to survive? What's next for corals? And I'm quick to remind folks that that really depends on us and our choices. And so this is just wanted to end my comments here by noting that since I saw that coral reef death on my research site, and since I kind of witnessed that up close and personal, you know, my research has become really quite personal to me, and the solutions have become quite personal to me as well. And so I wanted to share with you some of the lessons that I've been thinking about in solutions, because we don't have to choose a future that bakes the coral reefs that we know and love out of existence. We can choose a future where corals can thrive along with us as they have for thousands and thousands of years, and provided fish and habitat and sustained the global oceans for millennia. And this is some of the choices I'd like us to think about when we think about solutions to our climate problem. So on the bottom left here, you can see a house with solar panels. I just got solar panels on my house after 14 years in Atlanta. And you're like, why are you a climate scientist? Why didn't you get the panels before? I guess I didn't really think it mattered very much, but now I understand that if we all do this together, one step at a time, it can add up to a lot, and it just might be enough. But if I sit it out, and like everybody else, we just sit it out, well, then it's not going to be enough. So this is why I've started doing all of these different kinds of things. I bike to work. There's a picture of a bike here. I started biking to work in 2017 after that experience with the coral reef. My kids bike to work and walk to work. Actually, they don't work. I wish they worked. I wish they got paid to go to school, but yeah, quite the opposite, actually. And so they bike and walk to school. I also plant trees in Atlanta. So, trees are an incredibly important part of the climate solution. They suck carbon dioxide out of the sky, and they're doing so today every single minute around the world. And what would it be like if we actually deployed trees at such a scale that could actually sequester even more carbon dioxide? So it's like a very low-tech solution. People always want to think about solar panels and speed bullet trains, but this is something that nature has invented over millions of years to help us out, and we should use it. And of course, I have the bullet train. I take the train around this country now instead of flying whenever I can. Flying is the largest source of carbon dioxide in my life. Before I started thinking about ways of avoiding flying when I can. And so I take the train where possible, and I take buses where possible, or sometimes I don't even go. And like today, I present remotely to a bunch of my colleagues or students or other folks that I want to speak to. And the first thing I did in my house, the very first thing, was replace all the light bulbs. And so it's like, oh, it's just a light bulb. Well, actually, that light bulb is 10 times more efficient than the light bulbs that I had in my house before. And so my energy bills went down immediately. I was actually, even as a scientist, impressed by how big that impact is and how much money I saved. So that's some interesting things for kids to think about. What are some choices that you might be able to make in your family and talk to with your parents about what kinds of choices they might want to make? And so how can kids help? Let's get a bit more specific about things that kids can do to conserve greenhouse gases and start to reverse climate change when we all act together. So the first thing is to conserve electricity. This is extremely important. We are incredibly wasteful with energy on our planet. And here in the Southeast, we're particularly wasteful because we just don't have efficient houses, and we need too much AC to cool us down and too much heating to heat us up in the winter. Over there in Canada, in British Columbia, y'all are pretty efficient up there. And so you use a lot less electricity to heat and cool your buildings because you make them very, very efficiently. And so LED bulbs would fall in that category of energy efficiency as well. And don't waste food is the number 2 thing on this list, where you can see that if you do a study of how much greenhouse gases are coming from different sources across our planet, food and growing of food is about 25% of our carbon dioxide problem is from our food supply. And so why is that, you say? Well, the most important thing in that is that raising cows to eat cows is currently leading a deforestation of some of our forests. And this is happening all across the world, but especially in the Amazon jungle. And so when we cut down trees instead of growing trees, we're turning the knob in the wrong direction. And that red meat is causing a huge impact to our climate system. So that's the single biggest thing you can do, is stop eating red meat if you want to make a contribution to climate change and start to turn that food knob in the right direction. Obviously, wasting food is a huge additional problem in terms of climate change because it takes a lot of energy to grow food, and that's one of the core problems. The other thing I'd like to talk about is drinking bottled water. Here's my don't drink bottled water, buy a water bottle. So this is the message here is about not just single-use plastics, which are bad for the ocean, but actually most people don't realize how much carbon dioxide is locked up into that bottle of water. So they have to treat the water, they have to bottle the water, they have to transport those water bottles. Normally they have to chill the water before you buy it. All of these things add up to a huge carbon footprint for bottled water in particular. So don't let the bottled water industry make us perpetuate the idea that, you know, bottled water is just fine and it's the only safe water. We all have safe tap water in these neighborhoods that we live in, so we need to use it. I think I already said this before, biking or walking to school one day a week if you can. For me, it became addictive, and now we do it every single day, and I never thought that that would be the case because I love my car for 14 years. But you know what? This for us has been a hugely positive thing for us, my husband and I, and our kids. And the plant trees thing I can't overemphasize either. Trees make a huge difference in urban environments because they provide shade. They improve the way that water runs off and soaks into our ground so that we don't have these urban flooding events that can take down whole intersections or obviously sometimes flood homes. And so trees are a really important solution for climate change and impacts that we're facing down the road. And so this is a very low resolution graphic I'm noticing about how important plants and algae are to our carbon cycle today. And so for all the carbon dioxide that we put up in the sky through our energy use and our transportation, etc., plants and algae are already removing half of that every single year. And so when we talk about trying to get to zero emissions, what we mean is we want the outputs of carbon dioxide to equal the inputs. And so we don't have to get to zero emissions where we live in a cave and don't ever use electricity. We actually want to get to a point where we can only emit as much as those plants and algae can absorb. And that turns out to be a pretty sizable number. And I'm absolutely positive we can do it if we follow the kinds of steps that I've outlined in this presentation while we all move towards pressing our elected officials to listen to the science and listen to the data and help us along with some great policies that are out there too. So these are my 4 kids and I planting a tree a couple years ago now. We do this as regularly as we can during planting season. And last year, I think we planted 25 trees. And the last thing I want to leave you with is probably the most important thing of all. Are you ready? Guys, are you ready? It's really important. The most important thing you can do is to talk about climate change. Talk about the fact that it matters to you in your neighborhoods. It matters to your families. It matters to your cities. What do you think about coral reefs? Do they matter to you? What are the kinds of things that matter to you, and how does climate change come into that discussion? Because I'm telling you, climate change matters a lot to me. I saw it up close and personal, so I can tell some really amazing stories about the impacts of climate change as a scientist. But climate change touches all of our lives. And the choices that we're making today about climate change are going to impact your lives, your kids' lives, and your grandkids' lives. And so what do you think about that? There's a lot to talk about there with your parents, with your principal, with your teachers and friends. What can we do together about climate change in our neighborhoods, in our cities, in our states, that are going to help us move this dial? Because I just showed you it's not just going to be enough to wait for all these, the right politicians to get in office and do the right policies. We actually have to work on this together, each and every one of us, in our homes, in our schools, and in our cities. So I need y'all to work together with me talking about this problem. Studies show is the most important thing we can do to start this process of working together. So we're talking about it today. I invite you to go home and talk with your parents about it, talk with your friends about it, and keep this conversation going. And I can't wait to take your questions.